Hello, everybody. Thank you so much for joining us. This is such a great pleasure to welcome everyone to this amazing panel event and the launch of our expert seminar series on AI and machine learning for engineering. We are really very proud of this amazing panel that is coming together today. And for the kickoff of this event series and expert series that we are very excited about, what we are offering to everybody here is really the latest in academic innovation that we have at Berkeley. A way for practitioners, engineers, researchers, technical leaders to access this very latest know-how and best practices from outstanding global thought leaders as the ones we have here together in the panel today. All of this delivered in a unique format, combining this panel event with a 2-hour seminar series that will empower you to take critical strategic decisions for your own projects and for your own organizations. So we are really very honored and thankful to our panelists and speakers and our lead expert, Alexander Iliev here, for having put all of this together and for having taken the time to come together and share your expertise with our audience. Thank you so much, Alexander. Please take it away.
Thank you, Frederick. Thank you for the nice words and the introduction. It is my great pleasure and honor to be welcoming everyone here to this seminar titled The Latest Engineering Trends for Artificial Intelligence and Machine Learning. A few words about me first. My name is Alexander Iliev, and I will be the moderator for today's session. So please allow me to tell you a little bit about my background. I'm currently a lead instructor at the UC Berkeley Extension, teaching machine learning and TensorFlow, as well as Python for scientific computing classes. In addition, I am affiliated with the University of Miami, my alma mater, where I also taught classes in electrical and computer engineering. University of Wisconsin as well, at Stevens Point, where I was an assistant professor, and I taught at their data analytics program. I'm also associated with the Bulgarian Academy of Sciences, where I'm an associate professor at the Institute of Mathematics and Informatics, and most recently the SRH Berlin University, where I am a professor at their School of Technology in the Berlin campus, focusing on big data and AI. Finally, and most recently, I'm proud to also say that I became a co-founder and a CTO of a digital innovation hub called Innovation Valley. In the last several years, I've been involved in various projects, including digital signal processing and speech processing, also psychoacoustics, emotion recognition from speech as well, using signals and images. And all of that applied with machine learning was a good recipe to apply to different AI-related projects, including the development of smart systems and Internet of Things for different industries, such as media entertainment, where I actually come from, telecommunications as well, security systems, just to name a few. Given my background, it was natural for me to join the team and develop these AI series for you along with the UC Berkeley team, for which I'm grateful. As everyone here knows, the field has been progressively heating up in the last 7 to 10 years, and we at Berkeley felt that we have something to say about it, hence we developed these series. This is the reason why I was drawn down to this project, and this is why I am proud to also speak about our panelists next. So it's with great excitement that I want to introduce them. Next, we have Mr. Ali Ribai, who has been listed consecutively among the top 100 AI influencers globally. Through his global reach, Ali has been leading thousands of data enthusiasts all over the world with all the challenges of the new economy and fear of AI robo advisors replacing the role of human advisors. Of course, Ali brings his unique anthropological perspective to data and technology and present stories of the ways they are impacting our lives and jobs. I also would like to thank Dr. Michael Wu, who is joining us He's also a UC Berkeley alumnus, and he's one of the world's premier authorities on artificial intelligence, machine learning, data science, and behavioral economics. He's currently the chief AI strategist at Pros, an AI powered SaaS provider that helps companies monetize more efficiently in a digital economy. I also would like to thank Dr. Nasli Sifas, who is probably going to join us very, very soon. She is the applied science manager for Amazon's artificial intelligence, focusing on fairness and identifying biases in Amazon Web Services AI technologies. She formerly led the Amazon visual search team in Atlanta, which launched visual search for replacement parts in the Amazon shopping app in June 2018. This technology is a result of a former startup called PartPick from Atlanta, being acquired by Amazon at a later point, for which she was the chief technology officer, the CTO of this company. Finally, thank you, Nasli, for joining us. I was just introducing you. And finally, alongside, we also have our UC Berkeley Extension support team, our media team, thanks to whom we are filming and recording this beautiful event, as well as personal thanks to Christina Pinkney and Reje Torres, thanks to whom this event became possible. Now, I would like to give the floor to our experts, starting with Nasli, actually. So Nasli, maybe you can introduce yourself in your own words in the next couple of minutes and tell us what is your relation to the topic of this panel, namely engineering trends for AI and machine learning.
Yes, so thanks everybody for having me. I had a few technical difficulties. I think we're all kind of used to that now, but I'm very excited to be here. And as you mentioned, I am actually a tech evangelist slash former applied scientist at Amazon on the AWS AI team that focuses on fairness and mitigating biases in those technologies. And so I am been, of course, at the forefront of as a technologist of AI products and tools at from the startup company all the way to a company like Amazon, and worked at several other companies for short stints along the way. And also, of course, I'm a consumer of the technology, and I think it's very important to a lot of times when products don't work for us, we just assume, oh, okay, that's just the way it is. But it shouldn't be. It shouldn't be that way, and there should be mechanisms for us to have the same results of technology as the next person. And so that is something that I focus on. That's kind of my passion and advocacy behind machine learning as well as AI and those technologies. So.
Well, thank you very much for the explicit explanation. It's always nice to actually hear from your own words how you actually feel and what is the relation to this field from you. Personally, thank you once again. Same question goes to Ali. Ali, what drew you to this field, and what is your relation to this topic?
Thank you very much, Alex, for the introduction, and I'm happy to be here today. It's Ali Ribai. So I'm the president of Ribai Analytics Group. I started my company in my early 20s, and I'd like to call myself as a data anthropologist because I study social trends, ideological changes in societies, and I also research our ancestors' cognitive and cultural evolution. I believe that's very important in the age that we live in because it will help us stage emotional human experiences and human-centric AI. And I noticed what's really needed in this age for AI to achieve its promise is combining it with social sciences and with arts as well. So I'm looking forward today to discuss the challenges that engineers are facing to build successful AI experiences. And I believe that some of these challenges are common to all stakeholders, like we are talking about bias, about uncertainty, but still engineers play a very important role in building AI experiences now. So I'm happy to discuss this with Nasli, with Michael in the seminar today.
Thank you very much, Ali. Appreciate your answer. And finally, the same question goes to you, Michael. What is the connection your connection to the topic.
Sure. Thank you again. And I'm very happy to be here, and it's my honor to speak to all of you. And where I'm coming from is that have a lot of experience working with large enterprise who are, I would say, adopting AI. I think certainly the pandemic have created this acceleration towards this digital world, which is contactless, obviously, and probably safer and more efficient. So this is actually being pushed forward by the pandemic as well. And so as a result, I see that a lot of companies are struggling, to adopt this technology, even though there's a lot of, I would say, benefits that, from case studies, from everything that we have experienced, we know that there are benefits. But even so, the adoption of this technology, especially in the business world, has been, I would say, slower. Consumers have definitely, I would say, no problem adopting these type of technology, and business essentially are forced to follow. But is very often the case that for a consumer, when the AI doesn't work, right, it creates some inconvenience. Maybe we have to rephrase our question to Siri or Alexa or something like that, right? Or maybe so the cost, of an error, of a wrong decision in the consumer world is probably small. Something inconvenience, a loss of a few minutes or some little bit of time. But when you actually apply these type of technology in the business world, right, a wrong decision could be millions of dollars loss, could be irreparable reputation loss, and probably lost customers and trust and brand value. So these are very high stake decisions, and so business are very often reluctant to adopt AI for that reason. It's a fear of something goes wrong, right? So so I help a lot of company actually managing a team of data scientists to build this system and also help them launch and deploy successfully. So that's where I'm coming from.
Great. Thank you, Michael. Very interesting. Well, I just want to kind of clarify once again for our viewers that we have pre-recorded lectures from each one of our panelists. And as you can see, each one of them come from a different background, but still with the desire to excel in the same field, which is why I would like to get a little more details from them in the next several minutes, which reminds me that I wanted to ask actually Natalie next. Why did you choose to talk about different types of biases in your lecture titled "When Data Fails Us"? What is so attractive about it? Why do our viewers need to know about this?
Yeah, so again, it kind of all goes back to when we use technology, well, not us, of course, but consumers who use technologies that deal with AI. A lot of times they're not sure how the technology works. They assume, oh, this is a magical thing that we're just gonna take its word, whatever it says, that's what we're gonna go with. However, there's a lot that goes into it, and understanding that the data that you put into the algorithm very much so determines how robust, how accurate, how fair these AI models are, and how well it works on various groups, backgrounds, and intersections of those groups. And so it really, any AI or machine learning tool is really dependent, especially if you're training models and you're learning from prior data. It really is dependent on the data. I always say, my math teacher used to say, garbage in, garbage out, and just because you use a calculator, it's not going to guarantee you're the right answer. The same way with these models. And so when data fails us, what we've seen in industry, if you Google face recognition, if you Google biases in AI, you'll see all sorts of articles pop up. A lot of them are people concerned about their rights. When it comes to very mission critical use cases, when you have law enforcement involved or military using AI tools and technologies, and in some situations, of course, in less critical situations, like if I'm just trying to find pictures of my dog on my Google Photos, then of course that's not as detrimental to someone's health or their life. But when it comes to like healthcare and things like law enforcement, you want to make sure that the data is well balanced, it's well representative, and it speaks to and for the people that are going to be using that technology. You want to make sure you're not marginalizing any groups, whether that be different gender types, or that be different ethnicities, or age groups. All these things should be considered. We are working with humans, especially, and so we want the data to not fail us, because when the data fails us, then right off the bat, you have a problem. And so if we can continue, to get this data problem corrected, then maybe we can focus on some of the other issues that may exist. But it really all starts with that.
Yeah, that makes a lot of sense. Somewhere in your lecture, actually, you said something like keep fairness, be fair. This can sound like a very hard task to me. What is the best advice on how to maintain fairness in your approach? Is there a specific approach to remain fair? Is it something that you can summarize for our viewers?
Of course. So, and fairness can be defined in many different ways. You have a more practical view, and you have a more theoretical view of fairness. Sometimes people calculate fairness based on, how many different groups do you have? What are the error rates? Can you, minimize the error rates, maximize accuracy, and still have everyone along the same lines of error? That's one way to kind of balance it out. That's more of a practical way of thinking about it. But there are other equations and research out there that says, take a step back and think of the whole system as a model to calculate the fairness from. And of course, and that's not, I'm more of a practical person, but there's a lot of research that defines, how exactly do you define and measure fairness, and take these numbers and variables and constants across this entire equation before you even train the model. And so you can you can also approach the problem that way. And again, I focus more in my lecture on the data, but there are other aspects of fairness too.
Very interesting. Yeah. In another key takeaway I remember from your lecture, you said that an algorithm may be both correct and biased at the same time. Now, would you please clarify what is meant by this, and just kind of give us more details?
Yeah. So you can have, for example, so there's one use case. Let's say you have a application that you're building for a particular region to be used on a particular group of people. You already know who those people are. You already have the demographic information, and let's say that you want to tweak your algorithm to be to have the highest accuracy rate for this one group of people, because you already know what the application is. In that case, you're intentionally creating bias in the system. You're intentionally wanting to maximize the accuracy, minimize the error for that particular group. And that can be okay if that's what you set out to do, if that's your intentions. What we often find is that those are not our intentions, and this ends up happening a lot of times anyway. And so those are the use cases and the applications that we want to be extra careful for. But again, like there are definitely use cases where it's okay to be biased, and that's the intention.
Interesting. Yeah, that's very good to clarify. And of course, more of this our viewers can find in the pre-recorded lectures that we have already completed. Thank you, Ashley. We'll get back to you with after several more questions from our other panelists. I want to actually switch it over to Michael now and ask him kind of the same question as we started with Ashley. What made you select the topic industrial AI adoption, maturity, and challenges along the way? I mean, this is a very important topic because it has a lot to do with acceptance, with development, with basically modernizing every approach in every company. Michael, what is your take on this?
Yeah, certainly. I think this is a very important topic because just having consumers adopting this technology, right? It's good. But obviously, it's not good enough, right? To move forward as a society, and allow our, I would say, our life and our innovation and economic growth to progress to the next level, right? I think business actually need to be able to adopt these type of technology and be able to trust it and use it effectively and fairly as well, right? I mean, certainly, in a competitive world and as the business world, it is sometimes very, I would say, tempting to use this technology to in an unfair way to gain more advantage, for yourself, right? But there need to be, I would say, measures and put in place to ensure that that doesn't happen. And where I find this, is interesting, specifically relevant to challenges for trained data scientists and engineers, right? Is that very often, these are they're not really technical problems. I think we're trained to solve technical issues very well. I think we have a tool set, a toolbox, and a lot of experience doing that. But very often it involves, I would say, human psychology, it involves design, it involves legal, right? A lot of these are challenges that we are not trained in our background to handle these type of issues, right? So through my experience working through these challenges, I feel like this is provide me a completely different context of the breadth and of this topic, this AI, right? It has certainly the technical aspects to it, but it also has a lot of, I would say, other aspects around it that's actually very important for us to learn in order to drive adoption and usage of AI in the industry.
Yeah, great. This is a very explicit answer, and thank you, Michael, for that. But and we have conversed, you and I, before on this, and I see that quite often, that a lot of companies are saying that they're doing AI and they adopted AI, but then if you start digging up a little bit further, you see that this is not the case. In your view, in your opinion, why is it that many companies are still confused about what a true AI system is?
Yeah, I think that is very often a confusion because there's a lot of hype. Every company want to say that they're doing AI, right? I mean, even if you're doing some simple, I would say, data analytics, right? You would try to market yourself as doing AI, right? So that you get more higher valuation, higher if you're a startup, right? If you get more, I would say, interest and I would say conversation about you, because this is the topic, right? So I think that is the driver that created this confusion, right? I mean, but I think there's a lot of, I would say, misunderstanding as well, because AI is actually a topic that has evolved over many years. It started out, like I would say, all the way back in the 50s, right? I mean, but but maybe back then it wasn't called AI then. But I think over time, right, the definition of AI actually changes, right? I mean, I would say that back when you have simple things such as optical character recognition, people think that's AI because you have a machine, a system that can reprint, not only can it reprint, it can read handwriting, but not only your handwriting, but my handwriting and everybody else's handwriting, right? So that sounds like a something that intelligent machine can only intelligent machine can do, right? So they call it some AI, right? But today, like our phone could do OCR, right? And we don't consider that AI anymore, right? So I think that's
right.
That has created a lot of these confusions along the way because the definition of AI actually changes.
Well, you said it well there, because you said that OCR, we used to think that it's an AI, but not anymore, because this evolves, and AI actually it's redefining itself through technology, through advancement, and through finding and adopting new technologies. So in a very kind of a few words, Obviously, I want to make a big distinction here between companies and AI engineers that are actually listening to us. Probably some of them are trying to get the latest, so that they can become better professionals. But if you were to give a simple advice to a company, not to the engineer yet, we'll talk about them in the second portion of our talk, to a company, what would that be in order to adopt AI technologies? What would be the simple advice that you can give them? A single simple advice?
Well, I mean, the simple advice to, I always say that is the first step is to collect data, right? Because that's the fuel for AI, right? Collect data, collect enough data, ensure that they're clean, fair, well represented, as Nashla has mentioned, right? So that you have the fuel to drive this AI engine, right? I think that would be my advice as a first step.
That's a very good advice. Yeah, thank you very much, Michael. Now, to make it a little more dynamic, we'll get back to you and Ashley in a minute. And I wanted to give some time for Ali to speak to the crowd and tell us his take on all of these issues. Thank you, Michael, again. Ali, similar question to you. Let's start with you. What was the main motivation for you to choose this topic that you titled Building Human-Centric Machine Learning Solution?
I actually wanted to discuss the last point you were discussing with Michael, but
Sure, please.
Yeah, I believe like when it comes to AI, since the 1950s, we had the expert systems, if you all remember, where you had the knowledge engineer feeding an expert system that learn with the preset rules or symbols. But at the same time, if you need to apply that AI now, you cannot easily define the rules for a self-driving car to detect all the different pedestrians that it might face. So it had kind of limited possibilities. It won't account for every possible case. If you compare it to the AI that we have now, and I think Michael discussed that in his lecture, he said that AI is it's about learning and automation. So now, rather than trying to encode the high-level knowledge and the logical reasoning that we had with expert systems, machine learning now employs a kind of bottom-up approach in which algorithms kind of discern the relationship by repeating the tasks and classifying, for example, visual objects and images, or transcribing recorded speech into text, and these kind of things. And I believe if you ask me where things would be going, I believe where AI could be able to understand or draw from experiences and expectations, because until now AI can only analyze what it sees, and it cannot have a broad, non-conceptual understanding of the ideas and the phenomena around us. Because we as humans, we understand the sensory, the embodied environment around us, which AI cannot do until now. Now, moving to your question, why I chose the topic of human-centric AI. Let's go back to our ancestors, how we used to experience technology in the past. So if we have two hunting technologies, we have the atlatl and we have the arrow. Compared to the atlatl hunting, cognitive, conceptual, technological, and even behavioral flexibility were amplified when we adopted the arrow hunting technology. And the adoption of these new technologies can affect the way a society is even behaving. So the most significant difference between the atlatl hunting and the arrow hunting is that atlatl hunting is a group event. And in contrast to the bow and arrow hunting, which can be achieved with just one or two individuals, we needed a group to hunt with an atlatl. And what happened is that when we moved to the arrow hunting, we had a profound social change affecting almost every aspect of life, including who you marry, how big is your group, how status is conveyed. And shooting arrows with a bow, and on the other hand, it showed statistically significant high level of even neural activity and increased visual acuity, context updating, mental rehearsal, all these changes. And now, if you imagine the profound changes that AI could bring in this transition, because if you are talking about these tools, they were both the atlatl and the arrow, they are static tools. Now we are talking about a dynamic tool. If we are talking about an algorithm that learn by using, and the way we experience algorithms now is shaped by the uncertainty of how these data patterns are, and the parameters of the machine learning algorithms are converged in a model. So, for example, if we take Facebook, me as a user, I experience the news feed, the UI, but I don't know what's happening behind the scenes. So, the algorithm behind the scene for the news feed keeps on learning, keeps on changing without us knowing. We also don't know all the details of how the Facebook algorithm decide what to show us. So we don't know that. So what we see and experience is the news feed. The model itself, the machine learning model is probable, it's uncertain, and it's dynamically changing. So yes, here we can move to discussing uncertainties. When we know now, and we always come across model uncertainty or epistemic uncertainty and data uncertainty or aleatoric uncertainty. But we are talking here about also cultural uncertainty. So bias can even happen when you fail to understand the culture you are deploying the machine learning model for. So I believe these are important topics where engineers play an important role, and especially when they are developing these models behind.
Very explicit answer. Thank you very much, Ali. And it certainly is going to be more interesting to actually look into the lecture in details and get more of this in your talk. But in your lecture, you speak about phenomenology, and this is where I wanted to put a little bit of an accent on, and I would like to please clarify why is it important that phenomenology is important for AI, and what is the connection? Can you tell our viewers a little more about that?
When we talk about phenomenology, it's about experience. It's about understanding the context, about understanding the culture. And let me give an example that engineers face every day, which is ground truth problem. So in the course, I go over a different type of biases expressed by each stakeholder, from raw data to EDA to feature engineering, model building, and then consumption. And if we want to give you an example from Thomas Gregor, he's an anthropologist. He lived among people of a tropical forest in central Brazil. He discovered that in that culture, a tall man is worthy of respect, successful, powerful, while the short one is merely laughable, and he don't get the prestige in the society. So imagine a recruiting system where you are required to have, for example, a master's degree. The data can fix for you the bias of favoring short people instead of tall people, but it cannot go and fix the ground truth. It's tough for the algorithm to access that ground truth. So my meaning, yeah, you can if you fix the ground truth, it means that convincing that short people in that village with low self-esteem in that culture, they wouldn't even go to college or even apply for these jobs. They wouldn't do that. So it's a ground truth problem. It's not a data problem. It's not a machine learning problem. So if these guys don't go to college or don't have, because of a society problem. So so for me, if you ask me like, okay, how do you solve this? How do you solve the ground truth problem? It's not by data, it's by collaboration among different engineers and understanding the different backgrounds, different societies. This is where we can start kind of understanding these common issues that are faced by engineers now.
Interesting.
And it's about phenomenology, it's about experience and culture.
Yeah, that's great to clarify. Thank you very much, Ali. By the way, I can ask our panelists, they can pitch it at any time and just add their personal view on these questions. They can give us a short take on what they think about it. And another thing I wanted to mention to our viewers out there, I see that a few questions are coming in. Don't worry about it. We will address them as they come towards the end. So I'm looking into the queue and we'll follow that closely. So again, you can interrupt me at any point in time, any panelist, and then you can also add to the topics that we currently discuss. Going back to Nashley again, thank you, Ali, once again. We'll get back to you in a minute. Going back to Nashley, I know you worked on a very special project, and I when I was introducing you, I talked to our audience about it. What made you start working on the Part Finder project? Please tell us about it a little bit if you can.
Yeah, sure. So I was a student at Georgia Tech at the time, a grad student, working on finishing my PhD. As many people working who have done a PhD or been in grad school, you know how difficult that time is. It's very, very trying and challenging time in my life. And so I remember just trying to finish, and you know, you would have people and distractions try to come and take you away from what you're supposed to be working on. And whenever people would say, hey, you know, nationally, which happens quite often, hey, nationally, I got this great idea. I want to talk to you about it. And I'm like, no, just leave me alone, please. I just want to finish my PhD. But when I heard about this particular idea, it was a young lady, Jewel Burks. She was also a Black female, and she needed an idea for creating an algorithm that could recognize parts and images, and so like screws, nuts, bolts, washers. And I thought that, you know, one, I could help. Two, I was very happy to help her because she, you know, was someone who looked like me, and it was no secret. It's not a lot of women and Black women in the tech industry. And so, and three, you know, I thought it was a great idea. I'm a DIYer myself. I like to fix things, and I think that's the engineer in me. And so I was able to help her, and we were able to build this prototype. Uh, when we were working on the prototype, you know, I was getting ready to graduate, and she had the prototype, and I was tired of being a poor grad student, so I took a job in New York City with a consulting firm. But she was able to take that prototype, and after about several more months of fundraising, she was able to raise, I think it was $1.5 million and close that seed round. And then she needed a CTO, and so she called me back, said, "Hey, I need a CTO. Can you come back to Atlanta to be the CTO?" And that's how it happened. So.
Yeah, a lot of opportunities all of a sudden opening up, especially when you are in this field, and everybody knows that this is a very, very hot area, which is why we're here. Yeah.
Yeah, I think one more thing I want to say on that is that a lot of times, you know, people think of AI as this abstract thing that is unattainable, that is so, you know, hard to, you know, be engaged with and to understand. But if you really understand it at a high level, you can use it to your benefit. You can use it to solve a lot of your day-to-day problems, you know, whether you're a car mechanic or whether you're a hairstylist, you know, it doesn't matter. There's so many different applications. And if you just kind of sit down and think about, okay, in what ways can I use automation, even as an engineer, in what ways can I streamline something that I'm doing, and how can AI be applied to that, you'd be surprised how many ideas you'll come up with, and how many possibly successful startup companies you may already have in your Black notebook. And so just think about that. I would encourage you to just take some time out and just consider, you know, is this something you're interested in? Are you interested in starting your own company? Are you interested in applying AI into, you know, things that AI has never been applied to before? That's where the primitive innovation comes, and that's where, you know, that's where, as they say, that's where the money resides. And so that's
Sure.
what you want to consider, and you know, just think about that.
Yeah, absolutely. As you said it very well, where we don't think about AI as something that we can actually use in everyday life, and we can easily solve a lot of problems with it. But also there's the scare of using it, right? The insecurity of what it comes after. And Michael is actually talking about this in his lecture, specifically about equality and ethics and all of these issues that are coming up with new technology. I was recently asked, by the way, by an interviewer, so how do you test an intelligence of a artificial intelligence system? And I was like, wow, that's a deep question all of a sudden, because it could really have a very deep explanation. But the simple way is basically to say, well, it depends on the use case. I mean, there's so many different AI systems that they take decisions for us. They self-improve. It just depends on the way you apply it. But one more question to Ashley. Somewhere in your lecture, as a key takeaway, you mentioned start somewhere. that kind of resonated with me, and I wanted to ask you about this. Did you mean that we should just simply pick an interesting problem, and then somewhere along the way, as we're working, we may discover new learning methods and eventually converge to interesting solutions? What did you mean by that?
So yeah, I think when I say start somewhere, I mean you know, a lot of times we you know, if you have anxiety like me, you know, it's like, oh my gosh, I'm starting something new and I don't know where to start, I don't know what to do. It can be pretty simple, you know, just start somewhere. So whether that's reading a book, maybe you want to order something, a course on Udemy or Coursera, or even through Berkeley. Maybe you want to there are a lot of great programs now that are virtual because of the pandemic. You now have access to these tools and resources that you may not have access to before in your environment or in your you know, community where you live. And so now that we have this whole world out there, there's so many resources. Just start with one. Don't try to get overconsumed with all the things that you may need to do and what comes next. I just say, hey, just start. You never know. You may find something and you may catch on really quickly. You may find something and say, I really don't like this anymore. I'm not gonna do this, and that's okay too. That's what it's all about, trying to figure out what to do and where you belong. So
yeah, so be brave, basically. Be brave, start, and just go ahead and you know, they until you don't try or don't ask, you will never know. So it will be always a good thing to be involved and do something nicely.
And I want to echo a little bit.
Yeah, absolutely. Please, Michael.
Yeah, I want to echo what Ashley has said before, you know, about just starting somewhere. I feel like, you know, in other workshops that I've you know, given in a corporate setting, one of the things that, you know, I ask people to do is to identify something, I would say some task or some job that's repetitive and that they don't want to do. so that is actually a very good way to get this started, right? I mean, if there's something that you do this over and over again, right, and you don't like to do it, right, and very simply, you just have to find a mechanism to collect data on how you do these things under the different situation, right? For example, even when I just, you know, coming into the office or turning on the light, starting up my laptop and all that, right? So that's something that I do every single time, right? I mean, I wish I don't have to do it, you know. Then it's very simple. How can you automate this, right? How can you collect data and automate this? You can actually put a sensor in the door, right? Whenever you open the door, it turns on the light automatically, right? And you know, and it sends a signal to, you know, to your laptop to start up or something like that, right? So there are things like that, you know, that I would say, if you pay attention to the life around you, right? I mean, you know, I mean, this is a very simple case, right? It probably doesn't take us a lot of time to just switch on the lights and stuff like that. So it's a very simple automation. But if you look around your life, there are lots of situations, a lot of I would say engagement that may not be efficient. You know, that are, I would say, slow, and we have to do this repetitively, right? Over time and over, and we don't like to deal with it, right? I think those are the best place to think of ways where you could collect data around this context, right? And use those data to develop a model, right? And then help you automate those repetitive tasks, you know. And that would be, and I think that's already the first step, right? I mean, the way I like to look at AI is I always define AI as it's a machine mimicry of human behavior that has the ability to automate human decisions and action, and the ability to learn, which means they have to be able to improve its performance over usage, right? So
right.
Yeah. So I think that's actually the one very simple thing that everyone can do in you know, at their work or at home or wherever.
Yeah, thank you for your input, Michael. That actually makes a lot of sense, and I remember that mimicry term that you used in your lecture, and it makes a lot of sense to me as well. But as we know, AI has a maturity curve, which is something that you talk about in your lecture. So I wanted to kind of extend that question to your lecture now, give it kind of an extra step there into what would you like in your presentation? You talk about obviously the AI maturity curve, but would you please briefly tell our viewers basically what that means and what to expect from your lecture when you go into the depth of the AI maturity curve?
Well, I mean, the AI maturity curve is developed in a way that, to help company and organization to understand what's coming for them, right? Because there is a natural, I would say, adoption maturity, right? I mean, not everybody can turn into Amazon overnight, right? You have to start somewhere, right? So usually the first step is to, what we call digital transformation, right? It's digitization. It's it's collect data, right? And then the next step, would be to, exchange this data for some kind of automation. You build some model, right? But then these automated tasks probably won't do a perfect job, right? So you need to have the next phase. You have to kind of learn from human and essentially refine this model, this AI of this AI's model of how we work, right? And then after that, if you do this long enough, of course, this AI will be very, very good at mimicking how you work, right? And that would be I would say a good time for human to kind of let go, right? And to let the AI take over their job, right? And I think it's obviously a very good question, like what do we do then, right? I mean, then the same question as if you train an AI, right? I'm sorry, if you train a new employee or a new intern, right? If you train it well, he or she is able to do what's expected of him or her, right? Then you hire them, right? And then you become managers, right? You actually take on more responsibility. Your nature of your job actually changes, right? And then you move on to something that's more strategic, more important for the business, right? Rather than this mundane, repetitive task. So I would say that this maturity curve, it's developed in a way that's kind of vendor agnostic, and also like business agnostic. It's a natural progression of how AI adoption would occur in an organization, right? And it goes through, finally, you have the delivery of the last mile where you actually involve, autonomous AI running robotics, right? And then eventually we may even be able to support an AI augmented economy where I would say a lot of our repetitive work may be automated one day, right? So,
right. Yeah, that's the hope. And as you said, that there is a lot of doubt about that and how basically machines are going to take over our lives. There are huge ethical and moral questions there. And I've been asked recently by an interviewer this question. But that also kind of brings me back to where we started. And this entire talk is centered towards AI engineers and engineering in general. So I'm going to extend the question and the answer that Michael gave to Ali now. And I want to ask Ali, in your view, how can an AI engineer become an experienced artist who can design better human-centered AI products, as you talked about in your lecture?
Yes, and this resonates also with a question from Samuel here about trust. This reminds me of a leader, Julius Caesar. When he communicated to his army, he told his soldier that he won't march while ignoring their decisions. So he simply reminded them of who they are and trusted them to make the right decisions. And also Liverpool Football Club as well. What's happening there is the Liverpool football coach, he's acting as a business coach. He intuitively understands the numbers. He communicates with the data science department at Liverpool FC. And when they asked one of the players, do you know about this team? What do you think about the data science at Liverpool? He said that the coach doesn't hit us with statistics and doesn't hit us with analytics. He just tells us what to do. And the role of the coach is to foster that social learning, that team sport culture inside the enterprise. And similarly to the engineers who their role should be shifted from just focusing on the accuracy of the models and thinking more about how they can what we call epocare their customers. Epocare is like the suspension of belief, similar to when you watch a Netflix movie. You epocare logic for the sake of enjoyment, right? So you can epocare that for like the accuracy of models and the difficulties and the disturbances for the sake of creating unforgettable experiences and unforgettable spectacles for your users. So I believe that kind of mind shift is very important for engineers whenever they are working on machine learning applications.
Yeah, that sounds great. And in general, if you have to summarize, maybe you can also tell us what skills and qualities should an AI engineer possess in order to build a truly ethical system. When we talk about ethics, is a big topic. And Michael, I'm going to extend another question to Michael there about ethics. And please, guys, feel free to join the conversation. I don't have to, pick a side here. But Ali, what skills? Again, I'm going to repeat the question. What skills and qualities should an AI engineer possess in order to build an ethical system?
Yes, and before discussing that, I'd like to highlight one thing, the problem that we are facing, and I'll give an example for effective computing systems. What I'm seeing there is, for example, there is a pseudoscience in the late 19th century called phrenology, where it infers the interior character traits from exterior physiological science. So once you contour the skull, for example, it will send to AI to predict your personality traits and emotions. But whether engineers developing effective computing system nowadays realize it or not, they are always in danger of falling into these kind of fallacies. And they are making use of these pseudosciences in their work without them noticing. So your computer cannot detect someone's true emotion based on just facial expression. And
Right.
I'd like to highlight one thing from a philosopher, Prince, as I remember. He discussed something called the problem of parts. He said that emotions are made of physiological, mental, psychological, cultural, and also phenomenological components. So there is no single measurable element for the emotional response, and it can never tell you the whole story. So that's the problem, that whenever an engineer working on this kind of emotion detection, facial recognition, or affective computing system is to look into that areas that are not often discussed in the industry. To be curious, to look into not only the technical challenges, because I also mentioned something in the course. I looked into the different stakeholders of these systems, and there are often bias of focus in a way or another. So the engineer is focusing mostly on the accuracy of the model, and the decision maker is focusing on the ethical boundaries. So if we shift these roles, we will be able to get into what you are asking me. So that's very important, is to be open-minded, to be curious, and to understand these challenges, and not only focusing just on the technical aspects of the model.
Yeah, very interesting take on that. Anybody else wants to share? Michael, there's another question to you that I wanted to address next, and that would be about the topics of ethics and equality. I mean, why, in your view, the topics of those two, like the ethics and equality, they remain a bit overlooked? And is it something that because there is no direct monetization about? What is the main reason for this? Do you have any thoughts on that?
Yeah, I think there's the challenge is that, like, it's very difficult to define, an objective function for ethics, right? I mean, so, when you talk about machine learning or AI system, typically there's some kind of objective function that we optimize, right? And there's, whether you optimize it to find, the true optimal, or do you find the average optimal? there's a whole lot of, I would say, I think certainly some of the stuff that Ali talked about, the fact that we always focus on finding the model that actually minimize error or something like that. We focus on these hard metrics, right? Sometimes we overlook the fact that, there's a human aspect to it, right? So but if you actually can define, so there's actually a lot of, these affective computing, empathic systems, and they actually try to add terms into the objective function, right? To try to quantify, what is a good experience? What is ethics mean, right? So, but it's often very difficult to find, the term that actually, essentially, I would say, meet all the criteria of being ethical, right? I think legal is actually probably easier, right? So basically, if you have a system that has encoded all the laws, right, in our society, right? Basically, if you're anytime your solution go outside of the boundary of the laws, right, then your cost function becomes infinite, right? So basically, you have to force it to be constrained to be within the confine of this legal construct. But ethic is actually much harder. Sometimes it's a soft boundary. It's not like a yes, or black and white like legal, right? So, and it's very often context and use case dependent, right? And so these are challenges that I don't think we have a solution yet. I've dealt with this from time to time, and very often I have to deal with it case by case. But I think obviously what Nashley has talked about, it's very important, right? I think that the first step is to make sure that your data don't fail you, right? Make sure that your data is actually good, right? And beyond that, right, you have to still, introduce these auxiliary kind of terms in your objective function, right? Besides being minimizing errors or prediction accuracy and all that, right? What other terms do you want to put in there so that your objective actually mimics, for example, I want a legal AI, right? That's compliant to legal, right? Then I could put in those legal terms, which is a huge complexity, right? I mean, it's no longer I would say a continuous function that you can optimize, right? You have to, it's very complex, right? And when you're actually dealing with soft boundary, such as ethics, then it becomes even harder. So
absolutely, yeah, and as you mentioned, actually, Nashley had a very nice take on that, and I remember talking to her about some of the ethical questions that are still outstanding. Nashley, what is your take on the ethics?
Yeah, so I agree with everything that's being said here, and I just want to say, oftentimes I look at the typical engineering curriculum, even ABET accredited programs. There's usually, I think, one ethics course that's required, maybe. And most places, sometimes they wrap that into another course, right? But when I think about like my friends that have law degrees or my friends that are medical doctors, they have like a whole series of ethics courses, right, throughout their tenure in that program. And so maybe it's time for us as engineering departments and programs and careers to step up our ethics training for different industries. And so and that may be even more specific depending on what industry you're in. And so I think that we do have some ways to go before we can call ourselves pretty adequate in that area.
Yeah, absolutely. And that of course raises a lot of questions, and still the adoption of AI is a bit sketchy because of areas like that. There are little gray areas, as Michael said. It's not black and white. You cannot really say where exactly you can fall on the right or on a good side on this one. So yeah, absolutely, they cannot really brush it under the carpet, and it has to be addressed face on, and because it's a big challenge that is coming our way. But in that regard, I actually wanted to ask you another question here, Nashley. If you were to have like kind of several selected answer of the best advices for our viewers that you could give to any AI engineer that implements technologies, basically, what is the best advice you can give them to stay ethical, to be unbiased, or if they have to choose a side and be biased, in what situation they have to apply these? Any kind of a general kind of advice for our AI engineers?
Yeah, so I think at a high level, well, I think let me just take a step back, ethics and biases and fairness, they all have like, different meanings, and it really depends on, what the use case is and the application. I will say that in terms of the fairness and having unbiased AI applications, you want to make sure that um, in general, I say make sure you provide a lot of different perspectives at the concept stage of the product. So hopefully you have a very diverse engineering teams, across gender, age, ethnicity, backgrounds, regions, etc. And if you don't have these people, all these different perspectives on your team per se, we actually leverage focus groups, and we set up different groups and organizations that we can partner with to get their input. And of course, we can provide them, some incentive for participating in the focus group, similar to how people, take surveys and you get something for that. I think that that's a pretty good way to go about it. And also, I would say, as engineers and as scientists and developers, we have to be very conscious of the dynamics that are going on in the world or in whatever region it is that we're working in. So we experienced a lot last year in terms of social justice and racial equity, and when it comes to these things, especially in terms of law enforcement and using technologies that have humans in the loop or have humans applications, you want to make sure that we know that this particular, for example, race dynamic is very sensitive. If you go to India, for example, colorism is a big thing to be aware of, and you just want to make sure that you are aware of the social side and the social sciences that are happening in that particular demographic or group. Even so much to the point where you'll see now some engineering and tech teams have sociologists on their teams. They have psychologists on their teams or people in humanities that work really closely with them when they're trying to develop these technologies to get that extra input. And so that's what I would recommend.
Yeah, these are very nice advices actually, and as you can see, seemingly a simple sort of problem actually has a very complicated and much necessary solution. And if it's again taken full hard on and face on, then obviously that can achieve great results in the community. So thank you, Ashley. I will very soon start going to the Q&A section of our seminar today. But before that, I want to ask our other panelists like Ali and Mike a couple of other questions about final advices for our AI engineers. So question to Ali, what key advice would you give an AI engineer who wants to create an ethical human-centric system? Basically, because this is kind of the topic at the moment. What would you say?
I start from what Ashley was discussing, and there's something very important when we look at human sciences. For example, there's something called ethnopsychology. So different ethnic psychology studies how different ethnic groups react differently in different situations, in the ways they act or what do they say when they experience anger or when they experience happiness. So this could be due to culturally acquired rules of interaction, whether it is verbally or non-verbally. So if you are tourists, for example, traveling to another country, and then we perform ethnopsychology analytics, for example, we might interpret a smile from that ethnic group differently. It can symbolize politeness for one group, and it could be not happy. It could mean sad for another group. So this will help avoid bias when assigning more negative emotions to people of certain ethnicities than to others. So imagine or consider all the effects in the workplace where an algorithm identifying an individual as exhibiting negative emotions might affect his or her career progression. So looking into these things, looking into the human sciences, ethnopsychology when working with this model, and also when we talk about confirmation bias, one way of avoiding confirmation bias is to get a second opinion. So working in collaboration with other engineers would really help, because bias might even happen in the first phase. So if you are getting raw data, the raw data that you got might have a bias from the creator itself. So sometimes by coincidence, you might face someone from that culture who built that data, and you discuss with them and you understand, like the example of the tall and short guy that I just gave. So opening your boundaries is very important. Looking at social sciences, adding to what Nashli was saying, are very important, I believe, to building human-centric applications.
Yeah, absolutely. And in the topic of emotion, you and I spoke about that before. This specific topic is really challenging. It's not easy to answer because emotions are conveyed through many different ways and levels, through our body language, through a change of coloration in our face, through sweating, even of course, speech and facial expression. So judging a simple input of data is strongly unwanted nowadays, and it's obviously this is more scientists' only choice because of I guess lack of resources and data. But we have to always be aware that these findings are not they cannot really define the market or the way we should function, and it's also very, very cultural. As Ali pointed. Thank you very much, Ali. That was a very nice and deep answer indeed. And another question before we start answering questions from our audience here, they accumulated already. We have like 5 of them. I want to ask Michael, what is the best advice you could give to someone who is in engineering and is building an AI system, keeping in mind the challenges of business usually faced when adopting AI technologies? What would you say to them?
Yeah, I think certainly the understanding the business use case is crucially important. But I do want to echo some of the comments that Ali and Ashley provided. Yeah, certainly I think this, there is a having inclusive team, diversity of opinions is actually very important, right? But I think I would say most of the practical scenario is often very challenging to include all diversity, right? I mean, even the focus group, sometimes you have selection biases. You try to mitigate all these biases that's already known, right? But I think that one thing that we must not forget that, even though we try to have minimize this so-called bias, right? Sometimes it's actually we miss something. Inevitably, we do miss something. It's just that. And so one very important thing that we should constantly be watch out for is constantly monitor the output of the system, right? And constantly evaluating with the changing application, right? So you may, for example, the example that Ali mentioned about the tall and the short people, right? So if you only apply to that region, where this culture is the norm, right? Maybe that's okay. But if you're actually trying to take this system and apply to a different society where you have different culture, different norms, right? Then you need to evaluate it, and see how the people actually react to that, right? And constantly monitor and refine, right? I mean, I think this is actually how I see that, to be truly intelligent system, right? And to be truly calling artificial intelligence, they need to exhibit this character as, being adaptive, being able to adapt, right? I mean, we move into a different culture. We see different things, we see different norms. We adjust our behaviors, right? To fit in, right? To understand what is being polite, right? I mean, it's very simple things such as, in the pandemic world that we just all experienced, right? In Asia, in Taiwan, where I'm from, wearing masks is actually a common thing, right? During pollen seasons, when in cities where air pollution is very serious, people wear masks to as a gesture of politeness. It's to you don't want to see people
right.
like have runny nose and all that, right? So and coughing and stuff like that. So these are very different kind of cultural norms, right? But if you actually travel to Taiwan or to Japan, or you will see that, during the pollen season, people wear wear a mask, right? But whereas in some of the Western culture, these are seen as, this person is sick and not well, right? So this is completely different, right? So whenever we take these systems out of, I would say, the context which was trained and built, right? We need to constantly evaluate, right? And retrospectively kind of include more data, more information, and more actually constantly increasing this diversity, right? I mean, we grow as a human by accumulating experiences, right? I think in terms of the AI and data, they grow and learn through accumulating more information and more data.
Thank you, Michael. I really appreciate your answer. It was very explicit and very thorough. As we at this point, I think we should give a little bit of time for our viewers to actually answer some questions in the next 5-10 minutes, because I wanted to stay true to our commitment to wrap this up in 90 minutes. Thank you to our panelists. And now let's wait for some questions. I'm going to read some of these, the first questions. A question from Po Yang Huang. What kind of jobs, I'm taking this because it says words, but what kind of jobs will last in the next decades? Well, I think I can answer that very quickly, and please feel free to join in and correct me. But I read somewhere that 85% of the jobs that will be posted in 2030 are not known yet. Basically, that says a lot. I immediately after that, there's another question that comes. Well, what does that mean? Well, are we going to just not have jobs? Well, no. The focus of our jobs will basically shift to another level as we and eventually we're getting there. We will have more mundane and more repetitive tasks taken over by machines, which we already have. I mean, for example, in agriculture, all the machines that are planting seeds now, they are doing the job we were doing 100 years ago. So this is the kind of answer that I can give to the best possible kind of information that I acquired lately. But again, 85% of the jobs that we will have as job postings in 10 years from now are still not known what they will be. And that doesn't mean we will be jobless, right? We will have completely different focus. If any of the panelists want to say something about these questions, please bring it in.
Sure, I'll echo that a little bit, because I feel like this 85% is probably a little bit overrated. I think there will be a lot of jobs that's being replaced. I think that the nature of the job may change, right? I think, for example, I think any technology that comes along would disrupt, I would say, the job market, in the short term, right? But in the long term, they tend to create more jobs, right? I mean, but I think that 85% is actually quite high. I would say, I would say that for example, like if you think about the car, right? Before you have a car, right? People have drive horse carriages, right? But now you have, instead of these tender to horses, horse carriages, right? You have taxi drivers, right? I think taxi driver as a job title probably doesn't exist, before you have a car, right? But I think that the nature of the job, you use a different tool, but I think I would say as a society, the function that need to be performed, right, are still there, right? I mean, you still need to get people from A to B, right? And previously you use a older technology, right? You use horse, you use carriages, right? And now you use, a different technology, say, a car, right? But I think a lot of times I would say these technologies, it's simply a tool, right? It's a tool. We be doing, I would say, the similar type of job function, but using a different tool, right? So as a result, the job title may change, right? It may no longer be what it used to be. So I would say that maybe 85% of the job title may be unknown right now. But I would say I think that doesn't, but if you look at it from the perspective of the job that need to be done, right? For example, getting people from A to B, right? A lot of things are limited still by, I would say, the physics of the world and everything. So those still are, I would say, these fundamental,
right.
I would say, systems of physics economics and how society operates, right, require a certain function to be performed. Right? I think those
Absolutely,
still
yeah.
will be there.
Yep.
Yeah, I mean, change is very scary at the beginning. And we have seen in the industrial age, Luddites destroying the machinery and these kind of things. And now people are afraid of 5G and all these things. But if we think if we think about it, we as humans, we are masters of flexibility. We adapt to change. Since the Stone Age, we are masters of flexibility. So I believe with time we will be adapting to these. Especially that we are in a disruptive time. It's bigger than the disruption of the industrial age. We will face these challenges. We'll face what happened in the industrial age, but at the same time, as I said, like with time, we'll adapt.
Thank you both for answering. We've got two more questions I wanted to address before the time is up. And our next viewer, Atakan Poraz, is asking a question that is addressed to Mr. Ribai, but I think even Ashley could also take this, and any of our panelists. The question is this: how do you actually deal with sensitive information and precisions when working on a human-centric data? Are there any concepts to take into account, especially for the sex, race, and social classes of people? Since machine learning or AI is based on probability, there has to be a lot of burdens on the way, since humans are individual. What is your take on that?
I believe, if you remember, Alex, in my lecture, we had one example around that, which is related also to the phrenological fallacy and applications. And there are different research that showed different stereotype belief and different type of, even how different societies perceive sexual violence, for example. So, and how will this affect the applications? One of the examples, if you remember, a research by Harvard where there is a drone that could follow a lady when it's at night and light the road for her. And in different societies, and you remember we mentioned that the way sexual violence is perceived and accepted is different. So again, that's why we need to understand culture to know how we need to adapt to that culture in building these type of applications. And once the lecture is out, I think I have the extended answer to that question.
Yeah, thank you, Ali. And Ashley, if you have anything to say about this, we're more than happy to hear you in a few sentences.
Really quickly, I think targeting like the individual more so. We've been so focused on how do we get. This is my high level philosophy. We've been so focused on how do we get one model to work for everyone. I think, where now the focus is shifting towards how do we focus on these individual groups and getting these breaking these systems down to where we can tweak it for these individual groups to perform better. And that's a whole nother, form of research, I think, coming down the line.
Yeah, great. Thank you, Ashley. Thank you for your input. I've got a few more questions here that I wanted to address. One of our viewers, Samuel Nyarko, is asking the following questions. One of the AI challenges is the trust deficit. Non-AI consumers and even AI experts themselves are not clear how inputs lead to fantastic output that AI normally results to. How do you guys handle this trust deficit challenge in the industry community? Thank you.
I'll take that, because that's actually precisely one of the topic that I discussed in the lecture. Because there is a trust deficit, today, because a lot of people think that these AIs are black box that they could not understand, and actually that is starting to change now. Okay, I think that there are actually techniques out there that allow you to explain AI, explain this black box, right? I mean, so there's obviously the simple approach of using, I would say, interpretable model, right? Interpretable model meaning that, they're self-explanatory. You don't need to explain them, right? And, but then whenever you do use these black box type of models, such as deep neural network, random forest, and all these, model that have, many more orders magnitude number of parameters than data points, right? Then you do have to explain them retrospectively, and there are actually a whole discipline around explainable AI that's actually going on right now. Okay, and we are actually doing a lot of that, because very often in the business world, it's not good enough to say that I achieved like a 90% prediction accuracy, right? You have to tell why.
Exactly.
For example, sometimes it's required by law, right? If you are trying to have a system that determines whether to lend somebody money for a loan, right? If you reject them, you need to tell them why, right? You can't just say, the AI says you don't score high enough, so too bad, right? That's not gonna fly, right? So you're gonna you got shut down, right? Basically. So there's a lot of research, and I would say a lot of techniques out there that talk about how do we explain this AI, and that actually we cover in the lecture as well. And I think and then the other aspect of that, certainly explainable AI is one area that drives trust. Right? People understand things that they can explain, right? People trust things that they can explain and understand, right? But there's other aspects of it is around the whole design aspect of it. You could design the system in such a way that so that people could build trust easier with the system, right? I mean, if you I'm sure all of you have probably experienced something. If you try to key in some address in your GPS, right? And sometimes you may actually prescribe a route that's like, why does it prescribe me this route that I never take? And it's kind of strange, right? And it's kind of, so it makes you wonder, like, why is it actually giving me this particular result, right? And the same thing is in the AI, where it actually give you a result that you don't expect.
Right.
And all this have to you can design it in such a way to present the information in a way that's easier for people to adopt. And we talk about that in the lecture as well. So I know that we are short on time, so I wanted to pause here.
Yeah, we have
to get to further questions.
Yeah, we only have like 3 more minutes, and I wanted there are 2 more questions before I close down the session. Thank you once again, Michael, for your explicit answer. Irakli Chigolashvili, hopefully I said that right, is asking a very interesting question. Technology revolution is disrupting an increasing number of industry at a rapid pace. This will undoubtedly result in forced workforce shift or evolution. Is U.S. workforce prepared for disruption that will come from AI and ML workforce shift? In a few sentences, anybody? Maybe Michael, you can take it.
Sure. I think that currently, at the current stage, there's a lot of work need to be done. I would say that, I think there's certainly a lot of reskilling and retraining, right? I think that now that, I think the society is structured in such a way that, there's an education sector that's, responsible for training the workforce, right, to enter the workforce. And then, but I would say and then the industry is mainly focused on, economic growth and driving, so I think, in the future, I think that probably will have to change, for a company that are, I would say, able to access these technologies such as AI, like the big companies, right? And they have a responsibility, right? I mean, once when you certainly give you, I would say, tremendous economic gain, right? The thing is, like, what do you do with that economic gain? I think part of the solution is to, company may be required in the future to take part of maybe not all the economic gain, right? Because if you take all the economic gain away, right, why would they do this, right? But a part of the economic gain must be used to retrain and reskill people so that they or maybe, not just among the employee, within the community as well, right? So
actually, that actually ties up a little bit to the last question that I wanted to kind of introduce here, and that would be when AI, that's an anonymous attendee, when AI eventually takes over some repetitive tasks that have historically been performed by humans, do you all think that universal basic income will be necessary to ensure we don't create a huge income disparity? in a few sentences only. We only have actually we have just on time right now to end, but a couple of words, just literally. Anybody? What do you think about the disparity? Yeah.
I'll jump. Yeah, I think we do have to keep a close watch on that. We want to make sure that in my talk we talk about the different roles. People training data, people annotating data, people organizing that data. Those people are just as important as the people training the data and deploying the data. And so, because you want to make sure the data is good, and so salaries and things should be properly adjusted for that.
Right. Well, thank you very much. Thank you very much, Natalie, for clarifying this topic for us. I think we're out of time, and I would love to actually hear more from our viewers separately. Please follow us online. I will basically once again like to take the opportunity to thank our panelists for their time and effort on this project. I hope it was exciting to our viewers, and I certainly hope that you will join us further into these specialized courses where our experts review these and many other fine details on what we discussed today. And if you decide to take all 3 courses that we have pre-recorded already, you will receive a certificate of completion at the end. Once again, it was a great pleasure and an honor for me to be part of this event, to be here with you and discuss all these important issues. Please follow us online, and hope to see you again for our next seminar series, as I think this is just the beginning for us, and we will try to introduce even more interesting topics in the future. Thank you, and have a great day.